Hi, I'm David. I'm lead engineer for the deployment and coordination team at Verberica, and today I will demystify the deployments of Apache Flink. If you're new to Flink, you'll soon find out that there are so many different deployment options that you can choose from, and once you start deep diving into this topic, it can kind of make your head explode, and yeah, the experience may not be as pleasant as we would have hoped for. Uh, to address this, in this talk, we will introduce this new way of thinking about the Flink deployments. We will start with the most basic example, which is standalone session cluster, and we will kind of expand from there in different directions to see how far we can go. And at the end, we will establish this new framework that you can leverage to make a decision of which deployment mode is most suitable for you and your application. Let's start with the standalone resource provider. In this context, resource provider just refers to where the Flink resources comes from and how Flink makes use of them. The standalone is as simple as starting a new process. Flink doesn't provide you any crutches. You have to yourself make sure that all of the processes you start are well isolated and they don't conflict with each other. Uh, you have to make sure that all of the components are able to talk with each other over the network. But it's the most flexible and simplest solution that Flink offers. Uh, we'll start with the session cluster, which is this deployment mode that is there for ages. It's a two-step deployment where you first start a Flink cluster and then you submit a Flink job into it. If you download a Flink distribution from the internet, it already comes bundled with these scripts and examples that we can leverage to showcase this. We will start with executing the job manager sh command that will start a new job manager process. Job manager comes with these two components, the resource manager and a dispatcher. Resource manager is responsible for managing cluster resources that Flink can use to execute your workload. These resources are called slots, and it's this most basic unit of deployment in Flink. Uh, then there is a dispatcher, which is this RPC gateway that Flink clients can use to submit a new job into a cluster or to retrieve an overall status of the cluster and jobs the cluster is executing. So next thing we are going to do, we are going to run the top speed windowing jar example job with parallelism of 2, which means that our job will need 2 slots. Once we run this command, it will start a new Java process that will also execute the main method of our top speed windowing jar. Then it will build a new job graph and it will submit the job graph alongside the jar to the dispatcher. And now our dispatcher will start a new job master. Job master is a component that is responsible for a life cycle and execution of a single Flink job. There can be multiple job masters, one for each job in the cluster. So what happens right now is that the job master knows that it needs to slot to start executing our pipeline. So it will request 2 slots from the resource manager. Now we have a little problem because our resource manager doesn't have any slots available. So it just needs to keep track of these slots requests and wait for some resources to pop up in later stages. So what we have to do right now is to start another process that we call Task Manager. Task Manager is a Flink component that is responsible for the workload execution, and by default, each Task Manager comes with a single slot. It then register itself with the resource manager. It basically tells him, hi, I'm a task manager and I have a single slot. If you have any pending slot requests, feel free to send it to me. And I will make sure to offer my slot to an appropriate job master. So this is exactly what happens. Resource manager sends one of its slot requests to a task manager, and task manager offers its slot to the job master. Job master now has one of two slots. It needs to start executing the job, but it's still not enough, and yeah, basically it cannot make any progress because it needs all of the slots that it requested to actually start executing. So what we have to do right now is to start a second task manager. It will again register itself with the resource manager. Resource manager will send the remaining slot requests to it, and the task manager will offer its slot to the job master. Now the job master has all of the slots it needs, and it can start happily to executing. It can start executing the job. So now let's see what happens if we start a third task manager. It will again register itself with the resource manager, but right now the resource manager doesn't have any more slot requests it needs to fulfill. So it will just keep track of this newly available slot that it can leverage in later stages. But right now it has no use for it. For example, if we decide to rescale our job from the parallelism of 2 to parallelism of 3, we can do it right away, and we don't have to wait for any new resources to get allocated. Another option would be if we decide to submit another job into this cluster that only needs a one slot to start the execution, it can start executing right away without having to wait for anything. So this was a session cluster, or standalone session cluster. Standalone means we are just starting new processes. Flink doesn't make any assumptions about our infrastructure, so like everything is up to us. The session cluster means this two-step deployment where you first submit a cluster and then you submit a job into it. It's a perfect fit for interactive jobs. Another thing that we have seen so far is this passive resource management. It basically means that Flink waits for some external system to actually allocate the resources to start new task managers, right? In this case, the external system was us manually starting the new task managers. Then if we have more slots than we need, we're just waiting resources. And if we have less slots, then we couldn't start the executions. So again, we were wasting resources. This only holds true for streaming. For batch, it's a bit different story. So to address some of the issues of the session cluster, we have recently introduced something that we called an application mode, and it can be described as Flink as a library, right? Basically, its main purpose is to address this two-step deployment mode and to simplify it. So again, we will start with the Flink distribution that we have downloaded from the internet, but this time we will copy over the top speed windowing jar into the Flink lib folder, which means that our Flink cluster has now our job jar available on its class path. So what we can do right now is that we will execute this standalone job sh script, which effectively just again starts a new job manager, but there will be some slight changes. And it tells the job manager that we want to execute a job that we call top speed windowing. So right now, again, our job manager process starts, but the dispatcher have this hook that is executed after it starts. We call it application dispatcher bootstrap, and it basically just executes the main method of your jar. So you can think of it that your job comes embedded with the job manager. So right now, when we execute the main method inside the dispatcher, it again submits a job graph. We don't have to distribute the jars because we already have them on ClassPath. So the actual submission should be way faster. And again, dispatcher will now start the job master. Job master will request new slots from the resource manager. Then once we start some task managers, they will again register with the resource manager, and they will offer their slots to appropriate job master. Job master can now start executing the job, and again we have an extra resource that we have no use for. So just a little recap of the application cluster. This is the mode where job and cluster are bundled and deployed together. It leads to a slightly faster deployment because we don't have to distribute the jars. Because like once we would start executing the job, like our job master needs to send the jar to all of the task manager for the actual execution. And it's very similar to deploying any other application. It's as simple as starting a job manager process and few task managers. We don't have to do any job submission, and so it's fairly simple to start with. This is a very natural fit for containers, right? Flink already publishes official Docker image, which basically bundles the Flink distribution. And what we can do with the application mode, we can create our own job image that basically extends from the official Flink image, and we will just copy our job jar into this user lib directory that Flink automatically adds into the class path. Then basically we can do the same thing as we have shown before, but we can do that inside Docker. So right now we have perfect resource isolation, and yeah, it's very, very simple to use. Again, we don't have to distribute the distributed job jar into the cluster because both task managers and job manager, they already have the job jar on the class path. So if we look into this in context of Kubernetes, we can now simply take these Docker images that we have just created, and we can create a simple deployment, one for a job manager and second for task managers. It's very simple. It's basically the same as deploying any other application on Kubernetes. Last thing that I want to discuss with this standalone resource provider before we do a little demo is something that we call a reactive mode. So far, if we had more or less resources than we needed, we were just like wasting resources and the precious computation time, right? So what if our pipeline or our like Flink cluster can automatically adjust to the newly available resources? Again, let's do a little example. Again, we will start our job in the application mode. So we will add the top speed windowing jar to the class path. We will start a new job manager that will automatically submit a job graph. We will then the dispatcher start a job manager, but this time job master doesn't initiate any slot request. It just declares its requirements. It basically tells the resource manager, I need at least one slot to start the execution, and I can have up to an infinite number of slots. So right now, when we start a task manager, our job master receives a slot and it can immediately start executing our pipeline without having to wait for another resources. If we add a second task manager, then our job master will again receive a slot, and it will now use the latest checkpoint that it has available, and it will automatically rescale the job to adapt to these newly available resources. If we then add a third task manager, our job manager will again rescale the pipeline using the latest checkpoint. Okay, let's do a little demonstration of this. We will submit submit this deployment into the Kubernetes cluster. We have basically these two deployments. One is for job manager. You can see we are using the official Flink image, and we're gonna be starting a top speed windowing job in this application mode. Also, we will switch the scheduler mode to reactive to demonstrate what we have just discussed. And we will start a single task manager. So if I apply everything, we should see that, okay. Okay, we can see that all of the pods are starting, and now we have a single job manager and a task manager. We can now port forward the web UI of the job manager to localhost. And we can now see that our job starts running. We have a single task manager with two slots. All of them are used, and our job is running. If we now decide to add another task manager, we can simply use this scale deployment command, and we will add a new replica of the Flink task manager. We can see it's now running. And once it joins the cluster, we can see that our pipeline now automatically adapts to the newly available resources. We can now add a third task manager. And again, if we wait for a little bit, we should see that new task manager will show up here, and our job will automatically rescale using the latest checkpoint it has available. Okay. Yeah. And you can now see that the job has actually restored from the checkpoint number 9, which was the latest checkpoint the job had available. So this was for the demo. Let's delete this deployment and we can now continue with the presentation. So what we have discussed so far was a family of passive resource providers, right? Because we were just waiting for the new resources to become available. We have a second family of resource providers, which we call active, and it basically means that Flink can do most of the dirty work for you. And if it needs the resources, it will just automatically and actively allocate them on your behalf. So it's basically like if you have a card, it's like you will give Flink the car keys and Flink will drive. So let's take a look at the native Kubernetes session mode. It's very similar to what we have seen with the standalone mode, just with little differences. Uh, we will first start a session cluster by executing this Kubernetes session sh command, and we will give this command name of the cluster, which is my first Flink cluster. And once we execute this command, the Flink client, which this command spawns, submits a job manager deployment to the Kubernetes API. It's very similar to just calling kubectl apply job manager deployment on your own, but yeah, Flink does everything for you here. Then Kubernetes will start a job manager pod. Once we decide to submit a job into this Kubernetes session cluster, we just specify the Kubernetes session target and the name of the Kubernetes cluster. So if we of the Flink cluster within Kubernetes cluster, because our Flink client needs to know which Flink cluster we want to submit a job to. It will simply discover where the job manager runs, and it will again submit the job graph into the dispatcher. Dispatcher will start a job master. Job master will ask for resources, but here is the biggest difference. Resource manager now doesn't have to wait for resources to somehow become available, but it will automatically allocate them. So it will submit a new task manager deployment that will, for example, allocate 5 task managers. These task managers will then again register with the resource manager. They will offer slots to the job master, and now your job is executing. And you didn't have to deal with all the deployment stuff around the standalone cluster. It's less flexible, but I can totally see how this could be very beneficial, for example, for the batch jobs. Then we have a native Kubernetes application mode. It's basically the same thing that we have shown with the standalone mode, but combined with the Kubernetes native integration. So you will just tell Kubernetes, I want to run this Flink application, and it will automatically spawn a cluster, submit a job into it, and allocate appropriate number of task managers. Then we have a Yarn integration. Yarn integration is very similar to the to what we have shown with the Kubernetes, except it has this one legacy deployment mode that we call per job. It's basically a special type of a session cluster that is deployed alongside the job jar that is then used for submission. And it will be most likely deprecated very soon in favor of the application mode. So if you're just starting with your deployment on Yarn, I would recommend going for the application mode instead. And then I would like to thank to Cloudera for taking over the maintenance of the Yarn integration. This is something fairly new, and yeah, we are very excited about it. Then last active resource provider that Flink has is Mesos. But for Mesos, I would recommend not using it because we have deprecated it in Flink 1.13 and we have removed support for Mesos in Flink 1.14. There were not many active users of the Mesos integration, and also the Mesos project decided to retire from Apache because they didn't have enough active PMCs. And I think right now they managed to get back, but it's more in a maintenance mode than, I don't know. Okay, so based on what we have learned so far, we can introduce something that I call the deployment decision metrics. It's basically a fancy visualization of what we have discussed so far. On one axis, you can change the nature of the resource allocations, which is either you want passive or active integration. Passive, again, means that you need some external system to allocate resources, or active is that Flink does everything for you. Also for passive, you can distinguish between how you make use of the newly available resources. Either you can use them statically. This means you just decide upfront how many resources your job needs, and you cannot change that later on. Or there is this reactive mode that can automatically leverage any newly available resources that pop up. Then on the second axis, you can choose between different deployment modes, namely between application mode, which is this single self-contained job, basically where you distribute a Flink cluster bundled with your job, or you have a session cluster, which is this set of long-lived resources, and you can use this cluster to submit interactive jobs into it. And on the third axis, you have various resource providers, standalone resource provider, Kubernetes native integrations, Yarn and Mesos. And I would also argue that there are special types of the standalone resource provider, but that's basically up to you. If you decide to deploy standalone on Docker, you can do it. You can deploy it on Kubernetes. You can deploy it on VMs, on bare metals, or on any other resource orchestrator you decide to use. For the long term, for streaming, our main focus will be on the application, standalone application with reactive mode. This is what I think is future of the deployment for streaming workloads. Okay, so this is all from my side, and now it's time for questions.